Simultaneous equations, part 3. So we've already had a look at linear equations as far as simultaneous equations are concerned. We've also taken a look at quadratic equations. We're now going to look at cubic and reciprocal functions. Now really these are the harder types of examples, and I think it's highly unlikely that these are going to come up in the final exam, but they are quite important in that they highlight two important techniques, two important steps as far as your algebra is concerned. So just take a look at the board. That's a quick recap. So just remember, anytime you're dealing with simultaneous equations, regardless of whether you're looking at linear equations, quadratic equations, or now, as the case is going to be, cubic or reciprocal equations, your steps are going to be exactly the same. So number one, you need to make one variable the subject of this equation. Number two, you need to substitute in that rearranged form of the equation into your other equation, and then solve them. Okay, just remember, once you've completed step two, you have solved your two equations simultaneously, essentially solving them both at the same time. And this means that when it comes to step three, so you would have found out either numerical values for your x values or numerical values for your y variable. And then when it comes to step three, you're going to find numerical values for that other variable. So if you found x in step two, you're going to find y in step three, and vice versa. Okay, so we're going to start off by taking a look at cubic equations, or a combination of a cubic equation and a quadratic equation. And the first thing you need to appreciate here, so this is our first equation, is that this is a cubic equation, i.e. you have a cubic expression on the right hand side because your highest power in x is going to be x cubed. So if I expand this out in full, I'm not going to do the full expansion, but if I write this out in full as far as the brackets are concerned, notice I have x plus 1 squared, which is the same as x plus 1 times x plus 1. That's this expression here. And now if I'm looking for my highest power in x, it's going to be when I multiply this x by this x by this x, I'm going to have x cubed, i.e. this is a cubic equation. So that's equation number one. Equation number two is going to be a quadratic. Minus 3x minus 1. Okay, so just remember, step one, you need to rearrange one of your equations such that either x or y is the subject of that equation. But if you take a look at both of these, they're already in that form, so we can jump straight to step two. So here, y is obviously the subject of this equation. You have y by itself on one side of the equation. Similarly, here, you also have y as the subject of equation 2. Okay, nice and easy. So step number two, I'm going to substitute. Normally you'd substitute a rearranged equation into your other equation, but I mean, what this looks like in practice here, so if I was say to replace my y here with my expression for y here on the right hand side, essentially all I'm doing is equating my two equations. X minus 1, x plus 1 squared equals 4x squared minus 3x minus 1. And now you know, so when we're dealing with a linear equations, once you combine your two equations, you'd be left with a linear equation. Similarly, when I'm dealing with quadratic equations, the equation you'd be left with here would be a quadratic equation here. This is actually going to be another cubic equation. As far as your steps are concerned, remember when you're dealing with quadratic equations, you need to move over all of your terms to one side of the equation such that the other side of the equation is equal to 0, and then you attempt to factorise. So that's what we're going to do here. So we need to deal with these brackets first. I'm just going to write that out in full, and now I will be forced to perform the whole expansion on the left hand side there. Okay, so let's do these two first. No, actually, let's do these two first. So I'm going to leave my x minus 1 where it is. I'm just going to expand this set of brackets out first. So I've got x squared, that one times that one, plus x plus x. Okay, I'm going to skip a step there. Plus 1. Okay, and obviously the right hand side stays the same. Okay, now multiplying out or expanding these two sets of brackets here, and multiply each of my three terms in the second set of brackets with my one term here. It's going to leave me with x times by x squared gives me x cubed plus 2x squared plus x minus x squared minus 2x minus 1, and then obviously the right hand side stays the same again. Okay, now just tidying up that left hand side there, x cubed. Now my terms in x squared, so I've got plus 2x squared minus x squared, so that's just leaves me with 1x squared. I've got plus x minus 2x, so that leaves me with minus an x. Here I've got just one constant number term there, minus 1. Okay, and then right hand side stays the same. Now remember, the objective when you're dealing with quadratic equations, or in this case cubic equations, you want to try and get everything to one side of the equation. So I'm just going to move each of these three terms over. Gives me x cubed. Okay, subtract 4x squared from both sides, and gives me minus 3x squared. Add 3x to both sides, plus 2x. Okay, now here, essentially I need to add 1 to both sides to move this over. So these just cancel. I'm left with 0. And my number terms disappear. And this is very, very important. So anytime you're dealing with a cubic equation that you need to solve in C1, this will be the case. You will not have a number term, okay? Because essentially, if you want to factorize a cubic, either you can take out a common factor, as is the case here, or you can factorize into 3 sets of brackets. You are not expected to be able to factorize into 3 sets of brackets for C1, which is what you'd be required to do if you had that number term. So anytime you're dealing with a cubic equation that you need to solve in C1, it's going to look like this with no number term. Okay? And that is very, very important. So factorizing this, I'm going to take out my common factor of x. Okay, I'm going to have 3 terms inside this bracket. What times by x gives me x cubed, so obviously x squared, minus 3x plus 2 equal to 0. And now, so if this was a quadratic, this would be fully factorized, or rather, once you get to this step, it would be fully factorized. But here, you notice I have a quadratic in this bracket, and lo and behold, you can actually factorize this down even further. Okay, so factorizing that quadratic there, minus 2 x minus 1 equal to 0. And now I can solve for my three x values, which is going to satisfy this set of simultaneous equations. So I'm going to have from here, so either x equals 0, or I'm going to do it like this, x equals 2, or x equals 1. So just solving each of these, so you know you need to set essentially this thing equals 0. So if x minus 2 equals 0, then obviously x is going to equal 2, and then the same for x minus 1. So I found my x values. That is step number 2 completed. I now need to complete step number 3. So I need to find my y values. So when x equals 0, this implies, it's probably going to be easiest if I actually substitute into this equation here. Just remember, because you've solved these equations simultaneously, each of these 3 values of x, it satisfies both this equation and this equation. So you can substitute in, you can substitute x, your x value into any one of these equations, and it will give you the correct y value. So I'm going to substitute into equation 1. So essentially you have 0 minus 1, 0 plus 1 all squared, which just equals minus 1 times by 1 squared, or just 1, which equals minus 1. Okay, so that's my first y value. X equals 2. Y equals 2 minus 1. 2 plus 1 squared, which equals 1. 3 squared. Okay, so 1 times by 9 gives me 9. And then lastly, x equals 1. Y equals 1 minus 1, 1 plus 1, all squared. In other words, 0 times by 2 squared, or just 0. Remember, anything times by 0 gives me 0. So just expressing these as my free coordinates here. So when x equals 0, so looking at this first one here, y equals minus 1. When x equals 2, y equals 9. And when x equals 1, y equals 0. So that is this first set of first set of system of equations solved simultaneously. We're just going to look at another example just to illustrate this point here. So I was saying that these questions are quite cleverly constructed such that you will not have a number term here because you're not expected to be able to factorize a cubic into 3 sets of brackets. So let's just quickly take a look at another example where this might be the case. So if I have this, 3x minus 1, 2, x squared plus 1, x minus 1. Okay, so we're not going to go through the whole question here. Your steps are going to be exactly the same. I probably will go through this entire example in my notes if you want to have another look. Okay, but step number 1, so it's already rearranged. You don't need to do that. You can jump straight to step number 2 and substitute one equation into the other one, i.e. this. And just a quick note on equation 2, that is a cubic. Okay, here, although we don't have 3 sets of brackets, your highest power on x will be x cubed because you have this x squared term here times by that x there. So expanding this out, and just to prove that, so you know, x squared times by x gives me x cubed minus x squared. Now dealing with the second term, plus 1 lot of x minus 1, which equals x cubed. Oh, so that's all done. No further simplification required. Okay, but just look what happens when I try and tidy this expression up. Okay, so all I'm going to do, move these 2 terms over here. How do I do that? Well, see, my x cubed term isn't going to be affected. My x squared term isn't going to be affected because I don't have x cubed terms or x squared terms on the left-hand side to bring over. So now I'm going to bring over my 3x. So subtract 3x from both sides, gives me minus 2x. Now here, this minus 1 is going to cancel with that minus 1. If I want to bring this over, I need to add 1 to both sides. So essentially they just disappear. And what do we have here? Well, we have a cubic, again, with no number term. So in terms of your factorization, you're going to quite simply put this, take out a common factor again. I'm not going to go through the rest of the question, but I will do so in my full notes. So that's the key point that I was trying to make with this example here. It's looking at your cubics and the fact that if you're required to factorize a cubic, it's always going to be the common factor method of factorization. Very briefly, we're going to look at one system of equations where one is a reciprocal function and the other one is a quadratic function. Again, we're only going to do this to highlight one point that is very important as far as your algebra is concerned, rather than the steps themselves, because the steps, as mentioned previously, they're going to be exactly the same regardless of the combination of types of equations that you're looking at. So what we're looking at here is number 1, we have y equals x squared. Number 2, y equals 8 over x. And just notice here, again, similar to our previous example, we have these equations are already in the form such that one variable is the subject of each equation. So in this case, obviously, y is the subject of equation 1. Equation number 2, y is also the subject of the equation. So just combining these, essentially substituting this one into this one, I'm just going to replace this y here with my expression for y on the right-hand side there. Very simply, x squared equals 8 over x. And now this is the important point that I was looking to make from this video here. So when you have a situation like this where you have x on the bottom of a fraction, you need to multiply both sides of the equation by x to get rid of that fraction. So it's similar to when I have something like this, x over 2 equal to 3. how do I solve that? Well, I multiply both sides of the equation by 2 to get rid of that, the denominator of that fraction. And this is going to be exactly the same reciprocal function like this. I'm going to multiply both sides by x, gives me that. Okay, so x cubed equal to 8, so x is the cube root of 8, or just x equals 2 3 times. So there we have a repeated root. And then let's just finish off this question quickly. So x equals 2. We now need to substitute this back into one of our two original equations to give us our value of y. So choose equation 1 or equation 2. Sorry, not sure what's happening with my penmanship today. Not quite up to scratch. Let's choose equation 1. So y equals 2 squared, which equals 4. And if you just notice here, if I were to substitute x equals 2 into the second equation here, it would give me the same value of y. I'd have 8 over 2, which equals 4 again. So here I only have one coordinate, one point of intersection between these two curves. And that is at 2, 4. So important point to note from here is that when I get to this situation here, you need to multiply both sides of the equation by x to get rid of the denominator of that fraction on the right hand side there. Right, don't be tempted here. So if you notice, this actually gives us one additional solution. So we're going from a quadratic here to a cubic here. So essentially, if you're thinking quadratics have a maximum of 2 solutions, cubics have a maximum of 3 solutions. So in some ways you can think about this as adding a solution for x. What you can't do, however, is this. So if I have x squared plus x equal to 0, or equal to a number. Let's do something like this. X squared plus x equal to x. I know if you've done enough algebra, you wouldn't be making this mistake, but don't be tempted here to divide through by x. So this is wrong. If I divide through by x, you'd have divide each of these terms by x. You get that. That is wrong because here you're turning a quadratic into a linear solution. So if going from here to here, I'm going from a quadratic to a cubic and adding a solution, that's okay. This is wrong because I'm going from a quadratic to a linear and essentially I'm getting rid of a solution there. So just make sure you don't do that. Right? That was a key point from this video. If you're dealing with a reciprocal function, then you need to multiply through by x or whatever the denominator of that fraction is. That's okay, but that isn't. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.